Small hole of area cross section 2 meters square is present near the bottom of a fully filled open tank of height 2 meters. Now this is this diagram is not only for the hole which is near the bottom, but even for a general hole which is there at the side of a beaker, okay, or a tank. So if we see here, like let us take this point to be 1 and this point to be 2, and we apply the Bernoulli's theorem. So what is Bernoulli's theorem? This is P naught plus rho gh plus half rho v square is equal to constant. Of course not P naught, it's P, the pressure at that place. In both the cases, here the pressure is P naught only. Okay, so therefore we have P naught plus, now this is at a height h above, okay, so P naught plus rho gh plus half rho v square at 1, this should be equal to P naught plus, now here the height is 0, plus half rho v2 square. Now actually speaking, what is happening is, so if you see here P naught, so here the pressure is P naught, that is atmospheric pressure, it is at a height h, so here we are taking this height to be a small h, okay, half rho v1 square, here the velocity is v1, P naught, here the pressure is P naught, atmospheric pressure, plus 0 because like this we are taking at a height 0, and half rho v2 square, the velocity with which it is like coming out. Now in this case, if you see, what is happening is that this P naught and P naught will get cancelled, okay. Now since the tank is quite big, quite huge, large, so this velocity 1 can be neglected, it's very less, very less, so therefore we are taking it to be 0. So therefore we have v2 is equal to, now rho gets cancelled, so v2 becomes root over 2 gh, okay, so that's the entire derivation, okay. Now why v1 has to be taken as 0? Because simply a1 v1 is equal to a2 v2, so therefore v1 is going to be a2 by a1 into v2. Now a1, so here the cross sectional area is quite big, a2 is very small, so this is like almost equal to 0, very negligible, so therefore the v1 is neglected. So now what's the velocity? It's root 2 gh, so let us find out root 2 gh, so it's root 2 into g, which is 10, because it's mentioned that we can take g as 10, into height h, which is 2 meters, so this is root over 40, and a small hole of area cross section 2 millimeters square, so this is root 40 meter per second, that's the velocity v2. So therefore how much volume is being, like it comes out per second, so this will be volume velocity into area of cross section, so this is equal to root 40. What is root 40? It's around 6.3 meter per second 6.3 meter per second into area of cross section, which is 2 into 10 to the power minus 6 meters square, so this is equal to 12.6 meter cube per second, okay, and of course into 10 to the power minus 6 is there, so therefore the option A is going to be the correct one.